Our discussion for today is about the R sub E model of the common emitter configuration. We'll start off with an NPN BJT na walang mga external components, walang mga resistor, and walang mga capacitors connected to its terminals. The emitter, in this case, is directly connected to the ground, but in some configurations, pwede tayong magkaroon ng resistor at capacitor dito sa ating emitter. But for the purpose of derivation ng ating R sub E model, i-connect muna natin siya directly sa ground. The base terminal is the input terminal of the common emitter configuration, and the collector terminal is the output terminal of your common emitter configuration. The base and emitter junctions can be represented by a single diode. As you notice here, ang arrow ng ating emitter ay palabas. That's why ang diode natin ay pointing downward. So parang palabas din siya. No? So this is pointing outwards or pababa. Ito, this is also pointing outwards or pababa rin. And then the collector terminal or the collector side can be represented using a dependent current source. So bakit ganito yung direction ng ating dependent current source? Dahil ang direksyon ng ating mga kuryente ay ito yung ating IE, ito yung ating IP, and this is your IC. So it just follows the direction of IC. So this is just an equivalent circuit or equivalent model ng ating common emitter configuration. But we all know that the diode can be represented by a resistance. Ano ba yung resistance na yon? Remember yung R sub D na dinerive natin using Shockley's equation or the AC resistance. We can represent this as a single resistor. So kapag nag-apply tayo ng AC signal doon sa ating BJT, magkakaroon siya ng AC resistance. This is your R sub E. So nirepresent natin yung diode bilang isang resistance in the form of R sub E. And then you still have here your dependent current source. So we have the base, emitter, and the collector. This is the equivalent circuit of this one. This model can be further simplified into the R sub E model. In order for us to derive or determine the R sub E model, we need to simplify the input side muna. Okay, so kukunin muna natin yung input impedance natin, and then mamaya ito drawing natin R sub E model. For the input side, what if we applied an AC signal sa ating base? For example, a sinusoid. So maliit yung kanyang amplitude. We're expecting sa output na mas malaki siya, and it will be out of phase by 180 degrees. So it will more or less look like this. The input signal is represented by V sub I. So this is your input signal. Ang ating circuit, it has an input impedance. No? So think of impedance as resistance. No? Hindi siya R sub E. Why? Unlike the common base, no, R sub E kino-consider natin na Z sub I, and kapag merong external resistances, kinukuha natin yung parallel combination. Okay? But for this one, it's not R sub E. Kasi we have to consider the resistance then or impedance ng base and collector junctions. Okay? Since nag-apply tayo ng input signal sa input impedance natin ng ating circuit, no, it will provide us with an input current, I sub I. So these are all AC parameters. V sub I, in-apply natin sa input impedance or input resistance, magkakaroon tayo ng input na current or kuryente. Okay. So, what will be the voltage across the R sub E? As you notice here, yung V sub I is directly applied sa base and emitter terminals. That is why the voltage across R sub E is also equal to V sub I. So, nakaparallel, di ba? Or, just to simply state it, it's directly applied to R sub E. What is the current that passes through R sub E? Since this is connected to the emitter terminal, meron tayong kuryente na pababa. We call this I sub E. Okay? These are all AC parameters. take note of the subscripts. No? So yan ay naka-small caps lahat. First is, let us express the equation of the input voltage dito sa ating input terminal. So we have V sub I is equal to I sub I times Z sub I. So this is your basic Ohm's law para sa ating input terminal. So we have the input voltage is equal to the input current multiplied by the input impedance or resistance. And lahat ito ay AC parameters. Okay. Ano bang I sub I natin? Yung I sub I natin, papasok sa base. Therefore, this is also equal to I sub B, your AC base current. That's why we can replace this one by I sub B times Z sub I. Alright. What about the equation for this one? So another equation for the input voltage based naman dun sa voltage across R sub E. So we have V sub I. So dito tayo nakafocus ngayon. Ang kuryenteng dumadaan kay R sub E is I sub E. Kaya kapag minultiply natin itong dalawang to, IR, makukuha natin yung voltahe ng V sub I. So we have I sub E times R sub E. Ito yan. Okay? And then, we can express I sub E in terms of I sub B. So, this is equal to beta plus 1 times I sub B times R sub E. Okay? Ang beta plus 1 actually can be approximated into beta na lang. Kasi ang beta natin, remember, ang values nito depende sa model or type of transistor na ginagamit natin. Usually, nasa hundreds of range siya. And hundreds yung range niya. No? So, halimbawa, meron tayong, for example, 150 na beta or HFE na 150. 150 plus 1 is 151. So, hindi naman ganun kalaki yung difference niya. That's why we can approximate beta plus 1 into beta na lang. So, this is beta times I sub B times R sub E. So, we have two equations for the input voltage. Input voltage sa input side and input voltage doon sa ating R sub E. So, dalawa yan. Pero pwede natin i-equate itong dalawang equation na yan dahil parehong V sub I naman yan. Okay, so let's write it on this part. So, we have I sub B times Z sub I is equal to beta times I sub B times R sub E. We can cancel out I sub B. So the input impedance of the common emitter configuration is equal to beta times R sub E. No? So, sa common base before, discuss natin, no, ang input impedance niya ay equals R sub E. So, mababa ang input impedance ng common base. While for the common emitter, it's being multiplied by beta. That's why mataas ang input impedance niya compared sa ating common base. So, the input impedance is beta times R sub E. After determining the input impedance or Z sub I, pwede na natin ngayon i-draw ang R sub E, common emitter model natin. Ang input side natin is represented by a resistor. Now, it's labeled as beta times R sub E. Now, unlike sa common base, ang input impedance natin is R sub E lang. Okay. Our output side is represented by a dependent current source. Ang I sub C natin is depende sa ating I sub B. Ang arrow nito ay pababa dahil ang direction nitong ating I sub C ay papasok sa collector terminal natin. So, sinusundan lang niya yung direction ng I sub C. What if we apply here an input signal V sub I? Okay? What will be the current that will pass through our beta RE? Diba, this is your input impedance. Right? Which is beta times R sub E. Now, ano ba yung kuryenteng dumadaan sa beta times R sub E na yan? Diba, this is connected to the base. Magkakaroon tayo ng input current na AC. But this is also equal to I sub B. Ang kuryente across beta RE is V sub I in this case. Now that we have derived the R sub B model for the common emitter configuration, pwede na natin i-apply ito sa isang configuration ng common emitter. So, i-apply muna natin siya sa fixed bias configuration. Sa fixed bias configuration, remember, meron tayong dalawang resistor na konektado sa base at sa collector terminal natin. While ang emitter natin is directly connected to the ground. So, this is your fixed bias configuration. So, this is the easiest and the simplest of among the common emitter configurations. Meron tayong input at output coupling capacitors na 10 microfarads each. But as I've said before sa ating previous lecture, no, yung mga value nito, hindi lang basta hinuhulaan yan. No, kinukompute natin yan, depende sa driven impedance. So darating din tayo sa part na yan. No? So we have 470 kilo ohm resistor for RP. We have 3 kilo ohms for RC. We have 12 volts VCC. We have a beta of 100 and an output resistance of 50 kilo ohms. So, ano kaya magiging effect no, kapag isasama natin 50 kilo ohms na yon sa ating R sub E model? Ito yung mga pinapasolve sa atin. We have R sub E, Z sub I, or the input impedance, the output impedance, Z sub O, the voltage gain, and the output impedance and the voltage gain with the 50 kilo ohm output resistance. Our first step here is to do a DC analysis. For the DC analysis, kinakailangan natin makuha si I sub E or the DC emitter current. Remember, ang R sub E kasi, ang equation natin dyan is 26 millivolts divided by I sub E. Therefore, the AC resistance, the AC emitter resistance, is dependent on the DC emitter current. Okay, so that's why we should solve for I sub E. So it's up to you to solve for I sub E kasi napag-aralan naman natin yan before, so I won't do the DC analysis. We'll just focus on the AC analysis. Doing the DC analysis, magkakaroon tayo ng DC emitter current na 2.43 milliamperes. No? Yan ay gagamitin natin to get R sub E. So we have R sub E equals 26 millivolts divided by 2.43 milliamperes. So makakancel dito yung milli, matitira na lang ay volts per ampere, which is equal to ohms. So R sub E is equal to 10.7 ohms. So that is our R sub E, which will dictate our input impedance for the common emitter configuration. Now that we have calculated for the value of R sub E, the next step is to draw the R sub E model for our common emitter configuration. So we have the input resistance, which is dictated by beta times RE. So we have beta RE. And we have for the output side, the dependent current source. Yeah. So this is your base. We have the emitter. And we have the collector. All of those are expressed as in terms of small caps dahil AC parameters ang sinusolve natin dito. So this is the AC model then. Okay? So next na gagawin natin is to zero out everything that is not AC. So lahat ng DC dito sa ating circuit, i-zero out natin lahat. No? So for this one, no, ang 12 volt supply natin is DC. That's why i-zero out natin siya. So paano ba natin sinizero out ulit yung DC power supply or DC source? We simply connect a short circuit sa kanyang terminals. Or, to put it simple, pwede natin siya i-directang i-connect sa ground. So this is just for the purpose of determining the R sub E model. No? Hindi natin talagang sinu-short out yung ating power supply in real life. Okay? So, nung nilagay natin sa ground yung ating VCC kanina, no? Ang R sub E natin ngayon ay direktang nakakonect sa base at ground. This is your base, this is your emitter. na nakakonect sa ground. Therefore, yung R sub B natin ay ilalagay natin dito ngayon. So this is your R sub B. Kasi nga, since yung VCC ay kinonect natin sa ground, yung ating R sub B will be placed in between the base and emitter terminals ngayon. But what about for R sub C? Ganun din. It's between the collector terminal and the ground. E di ba yung ground nga natin konektado sa emitter. Therefore, for the output side, magkakaroon tayo ngayon dito ng R sub C sa pagitan ng collector at ng ground. Collector and ground. Okay? But what about for the capacitors? Lahat ng capacitors natin are assumed to be short. No? Gagawin nating short circuit lahat ng capacitors natin under AC analysis. So, magkakaroon tayo ng parang wire na lang dito. So, this is where your capacitors are placed previously. No? So, wala namang effect dun sa ating circuit yung ating capacitors. But take note, kung mali yung pagkakakompute ng values ng capacitors natin, no, it will have a small impedance, yung tinatawag natin na reactance, which can have a substantial effect sa ating signal. Kasi kung masyadong mataas yung ating reactance, maaring yung signal natin mapunta doon. So that's why kinukompute talaga natin yung values ng ating coupling capacitors and yung mga bypass capacitors para maging short circuit siya pagdating ng AC analysis, no? At a certain frequency range. Okay, so this is your R sub E model. Next is, we will write down the induced currents para dun sa ating R sub E model. So mag-a-apply tayo dito ng input signal, which is represented by V sub I. Dahil nag-apply tayo ng input signal sa ating input terminal, no, magkakaroon tayo ngayon ng input current. No? Yung input current na yun, which is AC, mahihiwalay sa pagitan ng RB tsaka ng beta RE. With this one, we can do an approximation. Ang R sub B natin is equal to 470 kilo ohms, while ang beta RE natin is equal to 1,070 ohms or 1.07 kilo ohms. Mas malaki ang value ng R sub B compared sa beta RE natin. That's why we can approximate na yung ating I sub I ay mapupunta kay beta RE since mataas ang value ng R sub B natin. Diba current takes the path of least resistance. That's why I sub I can be approximated to be I sub B. Right? What is the voltage across R sub B? Since ito yung V sub I natin, kung mapapansin natin, no, yan din yung ina-apply sa R sub B. And at the same time, that's the same voltage or signal that's being applied to beta R sub E. So, lagyan lang natin labels. No? So, we have 470 kilo ohms. And then we have 1.07 kilo ohms. Next is, let us now calculate the input impedance. For the input impedance, as I've said before in our video lecture, minimeasure natin siya or kinakalculate before the input coupling capacitor. E di ba ito nga yung ating input coupling capacitor? Under AC conditions, lahat ng capacitors are shorted. So this is your input impedance. Looking into the input side of your circuit, ano ba ang resistances na nakikita natin? So we have R sub B, tsaka yung beta R sub E. So those are the determining factors for our Z sub I. But what is the connection between R sub B and beta RE? Hindi ba nakaparallel sila? Therefore, Z sub I, or the input impedance, is equal to R sub B parallel with beta R sub E. This is equal to 470 kilo ohms parallel with 1.7 kilo ohms. Solving for the total impedance or resistance of 470 kilo ohm and 1.07 kilo ohms, the input impedance is equal to 1.07 kilo ohms. So that is the answer for letter B. As you noticed, wala namang effect yung R sub O natin or yung ating output resistance sa ating input impedance. Ang nakaka-apekto lang sa value ng input impedance ay yung R sub B at yung ating beta RE. So let us write down here, J sub I is equal to 1.7 kilo ohms. Next, the output impedance. So how do we calculate for the output impedance? The output impedance is measured after the output coupling capacitor. Ito yung ating output coupling capacitor, which is short circuit na ang kanyang equivalent dahil AC analysis nga ang ginagawa natin. No? So this is your Z sub O or the output impedance. Ano bang impedance yung nakikita natin? No? But before that, maglalagay tayo ng resistor sa kanyang output terminals. No? Sa letter B, it is assumed to be infinite muna. Mamaya ilalagay natin yung 50 kilo ohms. So sa infinite muna tayo. Hindi ba't ang equivalent ng infinite na resistance ay open circuit? No? So hindi na natin kailangan ilagay yung ating output resistance para ma-solve yung output impedance natin. Kasi nga infinite yung assumption natin for letter C. Ano bang nakikita natin dito sa ating output impedance? No? Ang nakikita lang natin dito is R sub C. Therefore, Z out is equal to R sub C equals 3 kilo ohms. So let us write it here. The output impedance is equal to 3 kilo ohms. Next is letter D, solving for the voltage gain with the output resistance equals infinite or infinity. The voltage gain is calculated by this equation. Diba? Lahat ng gain natin is output over input. Since this is voltage gain, we have the output voltage divided by the input voltage. Sa input voltage, wala tayong problema kasi yan din yung ginamit natin earlier to derive our R sub E model. But what about for the output voltage? Ang output voltage natin is measured across your R sub C resistor. So this is your output voltage. No? Nagpasok tayo ng input voltage na AC. We're expecting na meron tayong output voltage na AC na amplified out of phase by 180 degrees. Right. Ano yung kuryenteng dumadaan kay R sub C? Since meron tayong R sub C dito, no? The current is I sub C, no? Which is also your output current, which is I-O. Okay, so we can write down the equation for the output voltage to be equal to negative I-O times R-C. So bakit negative? Kasi di ba ang convention natin, kapag ang kuryente ay lumalabas sa positive polarity ng ating voltage, negative yung nilalagay natin. And kapag ang kuryente ay papasok sa positive polarity ng ating voltage, positive yung nilalagay natin. But I out or the output current is equal to I sub C. No? Equal nga ba siya sa I sub C? Yes, kasi they have the same direction. Diba, before sa ating discussion ng common base, no, kapag salungat ang direksyon ng ating kuryente, they are the negative of each other. But since pareho naman yung direksyon ng output current tsaka ng collector, AC collector current natin, this is negative IC, which is AC, times RC. Ito yung equation natin for the output AC voltage. But what is the equation for the input AC voltage? Dito tayo magfo-focus. So parang yung kanina na ginawa natin. The voltage across beta RE is also V sub I. Di ba? V sub I din yan. Okay? So therefore, we can express V sub I in terms of the current and yung resistance niya. So we have I sub P, positive, dahil papasok dun sa positive terminal or sa positive polarity ng ating input voltage times beta R sub E. So this is the equation for the input voltage ng ating signal. Now that we have defined the equations for the input AC voltage and the output AC voltage, pwede na nating makalculate ngayon yung ating voltage gain. So we have A sub V, which is the voltage gain. That's just equal to the output voltage divided by the input voltage. The output voltage is equal to negative IC times RC divided by the input voltage of I sub V times beta R sub E. Hindi ba't ang I sub C over I sub B ay beta rin? Or ang I sub C over beta is equal to I sub B? This is equal to I sub C. Therefore, we can rewrite this as negative I sub C, R sub C, I sub C. Okay? And then R sub E. We can now cancel out I sub C. Ang matitira ngayon sa ating voltage gain is equal to negative R sub C over R sub E. So, ibig sabihin ng negative doon, hindi ibig sabihin na nag-decrease siya. Ibig sabihin niyan ay out of phase by 180 degrees ang input versus the output signal. Okay, so let us calculate the voltage gain. The voltage gain is equal to negative. RC is 3 kilo ohms. R sub E is 10.7 ohms. The voltage gain is equal to negative 280.38. Again, walang unit ang gain natin. So, that's kilo ohms over ohms. Makakancel yung unit. We have a unitless value. So, for example, nagpasok tayo ng 1 millivolt RMS signal dun sa ating input. What should be the corresponding output? The corresponding output will be 280.38 millivolts RMS. Sa RMS, hindi natin makikita yung phase shift. No? But kung i-consider natin yung graphical representation nito, makikita natin yung phase shift. No? Based on the instantaneous voltage or the instantaneous values. But nevertheless, magkakaroon tayo ng amplification. So kung meron tayong 1 millivolt, meron tayong 280.38 millivolts sa output natin. Okay? Next is letter E, repeat steps C and D. Pero meron na tayong output resistance na 50 kilo ohms. Next na pinapahanap sa atin is yung output impedance and yung voltage gain din. But what is the effect of the input impedance kung maglalagay tayong value ng output resistance? So, ilagay muna natin dito sa ating R sub E model yung ating output resistance R sub O. So, this is how we connect or this is how we place the output resistance sa ating output side. Meron tayong 50 kilo ohms. This is your R sub O. Nakaparallel lang siya dun sa ating dependent current source. Kanina sa first part, no, infinite yung ating output resistance. That's why open circuit yung equivalent niya. Ngayon ay meron na tayong specific value of 50 kilo ohms at paparallel lang natin siya dun sa ating dependent current source. Ano bang magiging effect ng RO na 50 kilo ohms sa ating input impedance? Wala naman siyang effect. Therefore, Z sub I is still equal to 1.07 kilo ohms. But what would be the effect on the output impedance, ZO? So, i-measure natin yung ating output impedance after the output coupling capacitor. But ngayon, meron na tayong dalawang resistors na nakikita. Kanina, di ba, ito lang yung nakikita natin, R sub C. Dahil open circuit yung ating R sub O. Anong connection sa pagitan ng R sub O tsaka ng R sub C natin? They are connected in parallel. That's why the output impedance is equal to 50 kilo ohms parallel with 3 kilo ohms, which is the value of your R sub C. The total output impedance is equal to 2.83 kilo ohms. As you noticed here, ano bang naging effect sa ating output impedance, bumaba. Pero hindi naman ganun ka-significant yung pagbaba niya. Kanina, that's equal to 3 kilo ohms. Ngayon, we have 2.83 kilo ohms. So halos walang effect dun sa ating output impedance. Kasi kung i-round off mo to, this is just equal to 3 kilo ohms pa rin. Now, let us calculate or solve for the voltage gain. To calculate the voltage gain, kapag meron na tayong specific value of R sub O, i-consider natin yung parallel connection dun sa pagitan ng R sub O at ng R sub C natin. So, kukunin muna natin yung total resistance niya in parallel, which is equal to 2.83 kilo ohms. And then, isi-simplify na lang natin to bilang isang resistor na lang. So, instead of R sub O at R sub C na nakaparallel, gagawin natin siyang isang resistor na lang. Simplifying the parallel resistors na R sub O at R sub C, magkakaroon tayo isang resistor na lang, R sub O parallel with R sub C. Alright? And then, our output current now will flow dun sa parallel combination ng dalawa. Sa unang analysis natin kanina, yung output AC current ay dumadaan lang kay R sub C. Pero, nung nagkaroon na ng R sub O, no, ang output current natin ay dumadaan na sa parallel combination ng dalawa. So, we have plus and minus output voltage and then palabas yung ating output current. Okay? Which is also equal to the AC collector current. No? So, i-define natin ngayon yung equation for the output voltage. We have the output voltage V sub O is equal to negative. So, dahil yung kuryente natin, yung output current ay lumabas sa positive polarity ng output voltage, maglalagay tayo ng negative na symbol or sign doon. We have I sub O times the parallel combination of RO and RC. But again, ang ating output current is the same as I sub C. So this is equal to negative I sub C times the parallel combination of R sub O times R sub C. What about the input voltage? The same pa rin. No? Kasi hindi naman naapektuhan, no, yung input voltage natin nung naglagay tayong specific value ng 50 kilo ohms for R sub O. Ang V sub I natin is still the same. Papasok yung I sub B sa positive polarity ng ating input voltage, and therefore positive ang kanyang sign. We have I sub B times beta RE. So we have the equation for the output voltage and the input voltage. Next is, let us now write the equation for the voltage gain. Now, output voltage over input voltage lang naman yan. This is the output voltage, negative IC, times the parallel combination of R sub O and R sub C, divided by I sub E times beta R sub E. Ang I sub B times beta is also equal to I sub C. So parang ginawa natin kanina, we can cancel that out. But let me write it down here, no, para maintindihan ng lahat. So this is equal to I sub C beta R sub E. I sub C times R sub E. Makakancel natin I sub C. Therefore, the voltage gain is equal to R sub O parallel with R sub C divided by R sub E. So this is your voltage gain equation kapag may value or specific value yung R sub O natin. Pero kapag infinite yung assumption natin for R sub O, ito yung equation natin. We have negative RC over RE. Kapag may specific value ng R sub O, ipaparallel mo muna yung R sub O na yun. So let us solve for the value of the voltage gain. We have minus 50K parallel with R sub C divided by 10.7 ohms. R sub C, by the way, is equal to 3 ohms. The voltage gain is now equal to negative 264.49. It's unitless, no? Kasi gain naman siya. So for example, nagpasok tayo ng 1 millivolt sa input of signal. Ano magiging corresponding output niya? Magiging 264.49 millivolts. So magkakaroon tayo ng amplification and magkakaroon tayo ng phase shift. Specifically, it's 180 degrees. So i-write down natin dito, we have a voltage gain of negative 264.49. As you noticed here, ang naging effect nung R sub O na 50K, bumaba yung ating voltage gain. But hindi naman ganun ka-significant. No, hindi naman naging from 280.38, hindi naman naging 10. Di ba? So hindi siya ganun ka-significant. That's why in most calculations, pwede tayong mag-assume ng value ng infinity for R sub O. Hanggang dito muna ang discussion natin for today. If you have any questions, i-post lang natin sa ating group and I'll try to answer it right away. That would be all and thank you. Have a nice day.